In this video, we discuss the questions related to the system of homogeneous and non-homogeneous linear equations that have appeared in the TS Telangana State set and AP set, Andhra Pradesh set examinations. These problems are also suitable for JL, DL and CSIR net aspirants also. We first discuss about the criteria for a system of non-homogeneous linear equations to be consistent or inconsistent. Consistency and inconsistency of a system of non-homogeneous linear equations whose matrix equation is AX is equal to B, where A is called the coefficient matrix and A, the matrix A along with the column vector B is called the augmented matrix. The first one is, if the rank of the augmented matrix A with B is equal to rank of the A, rank of the coefficient matrix, if they are equal, and equal to the number of variables, then the system is consistent. That means it admits a solution and the system has a unique solution. So in this case, that means the rank of A with B is equal to rank of A is equal to number of variables, then it is consistent and it admits a unique solution. Agreed. If rank of A with B is equal to rank of A less than the number of variables, then the system is consistent and the system admits infinitely many solutions. So when it admits infinitely many solutions, if the rank of the matrix A with B, the rank of the augmented matrix is equal to the rank of the coefficient matrix less than the number of variables, then the given system is consistent and it admits infinitely many solutions. If the rank of A with B, the rank of the augmented matrix is not equal to the rank of the coefficient matrix, then the system is inconsistent. That means it admits no solution. So the rank of the augmented matrix not equal to the rank of the coefficient matrix, then the system is inconsistent. That is, the system has no solution. So remember this, and we will now discuss 3 questions that have appeared in TS set and AP set examinations. The first question is from the TS set 2023 October session, and it is on the system of non-homogeneous equations, and it is the question number 60 and with question ID this one. Right. The question is, if the triad x0, y0, z0 is the unique solution of the system of linear equations, first equation, second equation, third equation. That means we are given 3 equations and in 3 unknowns, and it is a non-homogeneous system. Then x0 cube plus y0 cube plus z0 cube is equal to, we are given 4 options. That means if this given system of non-homogeneous linear equations admits a unique solution x0, y0, z0, then the sum of their cubes is equal to, we are given 4 options. Right. Now, the given system of non-homogeneous linear equations is, this is the system, first equation, second equation, third equation. 3 equations in 3 unknowns and it is a non-homogeneous system. Agreed. We will write down the matrix equation, matrix form of the above system is AX is equal to B, where A is the coefficient matrix and A with B is the augmented matrix. So where A is the coefficient matrix, that means this is the matrix consisting of the coefficients of the equations. So it is for the first equation, in the coefficient matrix, first row 97, 97, 140. For the second, similarly. So you will get A. Capital X is the column vector consisting of the unknowns x, y, z, and capital B is a set of the values that are given for these equations: 280, 151, 250, 237. Now what is the augmented matrix? Write down A with the extra column B. That is, the augmented matrix is A with B. So A is here and there is a screen B. This is the B. This is the augmented matrix. So now let's get into the discussion. So we have this augmented matrix. So our goal is to get this matrix, augmented matrix, into an echelon form. To do some echelon forms, so you have to do some elementary row operations. The first elementary row operation is R2. This second row, first column element, you want to make it 0. Third row, first column element, you want to make it 0. So to do that one, R2 is R2 minus 97 times R1, and to make this one 0, R3 is R3 minus, first of all, it is looking inconvenient. So R2 is R2 minus R1, R3 is R3 minus R1. Okay, we have done that one. Let's see that one. So the first row as it is, second row 0 will be here, and 140 minus 97 is 43. 43, 0 minus 43 minus 43. Right. So now what we see in the second row, 43 is common. In the third row also 43 is common. So divide the elements of the second row and the third row by 43. So R2 is 1 by 43 R2. R3 is 1 by 43 R1. Then it will be 0, 1, minus 1, 43 3 times, minus 3. And the third row will become 1, 0, minus 1, minus 1. So let's look at that. So that is the right. Now what we do is now shift the first row to third row to the first row to third row. That means interchange R1 and R3. R1 and R3. And thereby we will get the first row as 1, 0, minus 1, minus 1. And for executing elementary transformations, that will be easier. So exchange the first row, third row has become first row, and the first row has become the third row. Now make this third row first column element 0. So that's R3 is R3 minus 97 times R1. Do it. This will be equal to first row as it is, second row as it is, third row 97, 0. 97 is there, and this is 97 times minus 1 minus 97. You have to subtract. That means it becomes plus 140 plus 97. So 237, like that. This will become 377. Agreed. Now it has become a very convenient form. Now I want to make third row, second column to be 0. To make it, R3 is R3 minus 97 times R2. Right. Do it. So first and second rows are same. Then you will get this one. Now you see now 335 2 times is 668. So divide the elements of the third row by 334. So R3 is 1 by 334 R3. Right. Then you will get 1 0, so first two rows as it is. The third row will be 0 0 1 2. And now look at this. Now it is an echelon form. So it is in echelon form of the matrix of echelon form of not A, echelon form of A with B. A with B. Anyway, it is an echelon form irrespective of A or now look at A. Look at A. Look at A. Look at A. The rank of A is 3. Look at A with B. The rank of A with B is also 3. So we continue in the next slide. So A with B is this, and it is equivalent to this one. It is the echelon form of A with B, and the rank of AB, that is the entire matrix, is 3, and the rank of A, the coefficient matrix, is also 3. That is equal to the number of variables x, y, z. Three variables are there. So therefore, the given system is consistent and it admits a unique solution. Use that theorem. By that theorem, the system is consistent and the system has a unique solution. Let the unique solution be solved now. Solve these equations. Now from the bottom to the top you have to solve. So you take the third equation, z is equal to 2. Take the second equation, it is y minus z is equal to minus 3. That will be y is equal to minus 3 plus z, and minus 3 plus 2, that is minus 1. And up the first equation is x minus z is equal to minus 1, x is equal to minus 1 plus z, that is 1. That is 1. So what is the unique solution? X is 1, y is minus 1, z is 2. So thus the unique solution x naught, y naught, z naught. X naught is 1, y naught is minus 1, and z naught is 2. Agreed. We got. What is that we want? X naught cube plus y naught cube plus z naught cube is 1 minus 1 plus 8. 1 and minus 1 cancels, and you will get 8. So that is your answer. So let's look at our options. Our answer 8 appears against option 3. Therefore, the answer to this question is option 3. That is the detailed discussion of the solution of the given problem in the examination. Right. We will now move to the next question, and that question is also from TS set, but in the year 2018, and the question number is 16. This is the question number 16 from TS set exam 2018. The given question is, if the system of the equations, 3 equations, 3 unknowns, and non-homogeneous, and one of these equations contains a lambda, has no solution. If the system of equations has no solutions, then 4 lambda minus 8 is how much? So we are given 4 options. Right. So the given system of non-homogeneous linear equations is, the first equation is 3x plus 4y plus 7z is equal to 8, like that. The second equation, third equation. Now write down its matrix form. So that will be Ax is equal to B, where A is the coefficient matrix, and A along with B will be the augmented matrix, where A, the coefficient matrix, is 3, 4, 7, 2, 3, lambda, 1, 2, 4. X is the column vector consisting of the unknowns. Capital B is equal to the column vector consisting of the given values. Now write down the augmented matrix, that is the coefficient matrix along with the column vector B. Column vector B. This is the column vector B, and this is the matrix A. So this is the screen what we have. Now we continue in the next slide. Right. The augmented matrix is here. Now our goal is to convert this into an echelon form. Then we talk about the ranks. Right. To do that one, So you have to, we will interchange. It is inconvenient. If I have 1 in the beginning, then that will be very convenient for me. Therefore, interchange R1 and R3. So in the first row, 1, 2, 4, 6 will come. In the third row, 3, 4, 7, 8 will go. Right. So that is the one. Now, to make this 2, 1 element, A to 1 is 0. That means R2 is R2 minus 2R1. And R3 is R3 minus 3 times R1. Right. Okay. We have done. Yes. Why are we interchanging second and third row? Because it will be convenient if lambda, this equation consisting of lambda, is there in the third equation, third row. That will be convenient for the discussions. Right. So first interchange second and third row. So in the third row we have 2, 3, lambda 10. Now make that one. R2 is R2 minus 3R1. R3 is R3 minus 2R1. Then it will be 1, 0, minus 2, minus 5, 10, and 0, minus 1, lambda minus 8. 2 4s are 8. Right. 2 6s are 12. 10 minus 12 minus 2 will be there. Right. Now we want to make this to be 0. So for that one, what we have done is R3 is first multiply the elements of R3 by 2, then subtract the elements of R2. Then this will become 0. Right. So the third row 0 has become. Now what is that we want? Suppose we make it 2 lambda minus 11 is equal to 0. If then in this place 0 has come, the rank of A will be 2 and 6 is not equal to 0, whereas this is 0, then the rank of the whole A with B augmented matrix is 3. So the rank of the augmented matrix is not equal to the rank of the coefficient matrix. Therefore, the given system is inconsistent and it has no solution. So they are not equal. Therefore, the given system is inconsistent. That is, the given system has no solution if 2 lambda minus 11 is equal to 0. That is lambda. 2 lambda is equal to 11. Right. So what is that we want? We want 4 lambda minus 8. 4 lambda minus 8 is 2 times 2 lambda, that is 11, minus 8, that is 14. So let's look at our options. So our answer 14 will be appearing, is appearing against option 1. Therefore the answer to this question is option 1. And we wanted for what value of lambda that given system admits no solution. Then find out 4 lambda minus 8. That was the question. So that is the detailed discussion of the solution of this problem. And we move on to the next question. That question is from the AP set examination. Right. Now, this is a question that has appeared in AP set in 2018. And the question number is 14. The number of solutions of the system of linear equations given below is, we are given 3 equations in 4 unknowns, a non-homogeneous system. It's an equation in 4 variables. Because of 1, it is non-homogeneous. So we are given 3 equations in 4 unknowns, which is a non-homogeneous system. And we are given 4 options. You have to find the number of solutions of this system of the linear equations. How many solutions are there? That is the question. Solution. The matrix form of the given non-homogeneous system is, directly we are writing AX is equal to B, where A is 1, minus 2, 1, 2, right? And the second row 1, 1, minus 1, 1. Third row 1, 7, minus 5, minus 1. X is X, Y, Z, T 4 variables. B is given to be 1, 2, 3. Right. So now write down the augmented matrix A with B. And we continue. The augmented matrix is here, and our goal is to bring it to an echelon form. So R2 is R2 minus R1, R3 is R3 minus R1. Then it becomes 0 here, 0 here. Now we observe that 3 times of the second row up to this is the third row. Not here, not here. So we make R3 is R3 minus 3R2. Then you will get first 2 rows will be same. The third row will be 0, 0, 0, and here will be minus 1. Because minus 1 into minus 3, minus 3 plus 2, minus 1. Correct. Now look at this one. The rank of A is 2. The rank of A is 2. The rank of A with B is 3. So now rank of A is 2, rank of the augmented matrix is 3. They are not equal. And the given system is inconsistent because they are not equal. They are not equal. It is inconsistent. The given system has no solutions. What is the question asked to us? The number of solutions we have to find. The given system has no solutions. Therefore, how many solutions are there? 0. That is, the number of solutions of the system is 0. And let's look at our options. Option 1 is 0. So therefore, the answer to this question is option 1. That is the detailed discussion of the solution of the given problem. And questions of this type for a set is to be given. Why? Because it is not taking much time. Within 2 or 3 minutes, 2 minutes, you can do this one. See, because I am explaining, I am taking much time. But in the exam for you, it will take roughly 2 minutes. So questions of this type is welcome for any set examination. Let's move to the last question. So before entering into the last question, we talk about the system of homogeneous linear equations, because the next question is about system of homogeneous linear equations. So when you talk about the system of linear equations, there are 2 types. One is non-homogeneous and the other is homogeneous. We have already discussed non-homogeneous, therefore we will now discuss homogeneous. Right. A system of homogeneous linear equations, how that will be? Because it is homogeneous, Ax is equal to 0, not Ax is equal to B. B will be 0. So Ax is equal to 0 can either have the trivial solution or an infinite number of solutions. Trivial solution means unique solution, that is trivial solution, and infinite number of solutions. There is no question of inconsistency, there is no question of having no solutions. So either it will admit either a trivial solution, a 0 solution, or infinite number of solutions. In the case of homogeneous system of linear equations, if the rank of A is equal to R is equal to n, where n is the number of variables, then we will have the trivial solution only. The trivial solution is the only solution. There is a unique solution, that is a trivial solution. If rank of A is equal to R less than n, the number of variables, rank of A is less than the number of variables, then the system admits an infinite number of solutions, and the dimension of the solution space means the set of all solutions of this homogeneous system that forms a space called solution space. The dimension of the solution space is n minus r. In other words, in such a system, in such a situation, there will be n minus r linearly independent solutions. Agree? We move on to the next question. That is the AP set 2019. The year of examination is 2019. It is the question number 14. It is about a homogeneous system. The number of linearly independent solutions, of the following system, that is 4 equations are given in 3 unknowns, and it is a homogeneous system. We are given 4 equations in 3 unknowns x, y, z, and it is a homogeneous system. How many? We have to find out the number of linearly independent solutions for this system, homogeneous system. We are given 4 options. Right. 0, 1, 2, 3 are the options. Right. Solution. The given system of homogeneous linear equations is first equation, second equation, third equation, fourth equation. Right. Let's now write down the matrix form of the given system. Ax is equal to 0, where A is this 1, 6, minus 18, like that. The A is written, x, and the 0 is 0, 0, 0, 0. Yes, we have that matrix A. This is the 3 by 4 by 3 matrix. 4 equations and 3 unknowns is the matrix A from the last slide, and our goal is to make it in echelon form. So to make this one 0, this 0, this 0, so we will make R2 is R2 minus 4R1, thereby this becomes 0. R3 is R3 minus 3R1, thereby this will be 0. R4 is R4 minus 7R1, this will be 0. So let's do that. It is equivalent to 2. And luckily we got the first, second and third rows are same, and the fourth row is 2 times the second row. So we can very easily make it 0. So R3 is R3 minus R2 because they are equal. R4 is R4 minus 2 times R2 because it is 2 times. Then you will get the third row and the fourth row will be 0. This is the echelon form. And what will the rank of this echelon rank? Rank of A will be the rank of the echelon form. The rank of the echelon form is the number of non-zero rows. So therefore, there are only 2. Therefore, now the rank of A is equal to R is equal to 2 less than n, where n is equal to 3, the number of variables. And therefore, the system has an infinite number of solutions. Yes. Yes. And the dimension of the solution space will be n minus r. N is 3, r is 2, that is 1. The dimension means the number of linearly independent solutions. Therefore, that is the question what is asked in the examination, in the given question. The number of linearly independent solutions of the given system is n minus r, that is equal to 1. Let's look at our options. Our answer 1 appears against option 2. Therefore, the answer to this question is option 2. So, that is the detailed discussion of the 4 problems that I have mentioned. Two problems are from TS set and 2 problems are from AP set. And we have covered questions related to the given system of non-homogeneous linear equations as well as homogeneous linear equations in various cases. Great. And I am sure that you have understood the solutions of these problems, and I request you, please like, share and subscribe my videos if you like it, and I wish you all the best. Thank you.